value, right? So in this case, the cost is decreasing at each iteration. For batch gradient descent, we are clear that it will decrease with each gradient descent, but we cannot be possibly sure with the help of with stochastic gradient descent. We cannot be sure in the case of stochastic gradient descent, right? Because it might increase or might decrease also, right? Is it clear to everyone why the second option is correct? Yes or no? Okay. Okay, so next one is a calculation based question. So you are given four features for the given data set instance. You are given four features, that is x1, x2, x3, and x4, and you are given the values 3, 2.2, 0.5, and 2, right? And you are also provided with the theta parameter values and theta 0, that is the bias term that is provided to you. So you were asked to estimate the values of p of 1 given x, and if the true in particular instance y is equals to 1, then what is the loss value? So you had what will be the first step? You will be estimating the values of z, which is theta transpose x. Then you will estimate the values of hypothesis, which is 1 upon 1 plus e raised to minus z in the case of logistic regression. Then the loss function for the case of logistic binary logistic regression is of the form was minus y log of y plus 1 minus y into log of y hat. Oh, sorry, 1 minus y hat. And in this case, it was log to the base e. Okay, log to the base e, not log to the base 10. So I suppose everyone didn't do mistake in that one. So the correct answer is the one and x2, and your activation function which is used here is h of z is equals to 1 if z is greater than equals to 0, is greater than 0, sorry, and otherwise it is equals to 0. So what is the logistic function does it compute? So the answer is AND gate. It will compute, right? It will compute AND gate. So everyone is clear how it will compute AND gate here? You just have to calculate. What you have to calculate is W0. You have to calculate Z, which is W0 plus W1 X1 plus W2 X2. So you have to estimate. So suppose this value is greater than 0, then it will be equals to 1. Otherwise, this value will be equals to 0. Okay. So if you X2 are the two input values, and if you get you will be getting AND gate as an output, because for the given input, right? So this will give you AND gate as an output, right? I suppose this is clear to everyone. Okay. So the next one. So what is the output in this one? So if you recall in the AdaBoost algorithm, the initial weights that was assigned to all the samples in AdaBoost algorithm, this is the boosting algorithm that we had. So if you recall in the boosting algorithm, what was, yes, 1 by n was the initial weight that is assigned to all the samples, all the training samples that we had. Algorithm, what are we trying to do? What was the main content of all the data samples that we have? And then after performing the first classification by passing it into a decision tree stump, by passing the data set through a decision tree stump, we'll estimate that which of the predicted classification is correct out of all the classification, and those of which are misclassified will be those weight will be increased and rest of the weights will be decreased. So we had a particular calculation mathematical formula for that as well. So in this what we are asked is, we are asked for the given data set, what is the initial weight value that we have for all the weight that is assigned to all the data points. So in AdaBoost algorithm, the initial weight is 1 by 5, which is 0.2. Okay. So since we have 5 data samples here, so initial weight that will be assigned is 0.2 to all the data samples, right? Okay. So the next question is about for the given data set, what is the performance value and weight assigned to correctly classified point after each iteration? So if you recall, what is the formula for the weight assigned, weight update formula? Will anyone let me know what is the weight update formula? Sorry. Weight I plus 1 is equals to weight I into e raised to alpha, which is the performance, into actual output. Yes, actual output into predicted output, right? This was the value. Yes, h of x into. So you can also call predicted value as h of x, and this is the true output value, which is actually true output value, which is given in your data set. So it is already provided here. Your data set is already provided here. Target value is here. Actual output here. Predicted through the model. After passing it through the model, the predicted value. And performance formula is beta is equals to 1 upon 2 ln is the weighted sum of all the sum of all the weights of misclassified data set. So it will be 0.2 plus 0.2, which will be 0.4. So in this case, in that manner, you will be calculating the performance value, and then you will be calculating the weight updated weight. Okay, so answer A is the correct option. Okay. Yes. Is everyone clear with this? Okay. Okay, if anybody is having any doubt in any of the question, please let me know today in the chat section itself, or you may unmute yourself and ask so that we can clear the doubt in any of this question that you have, right? Okay, so next question is about in the, yes. Okay, right. Fine. So Priyank, if you recall in the AdaBoost algorithm that we had discussed in the classroom. So if you recall in the AdaBoost algorithm, what was the case? So first you have to estimate, here I am asking is you have to estimate the performance of the model, and you have to calculate the weight update for correctly classified. So correctly classified means what? If the predicted value y is equals to -1, y pred, okay, predicted output is -1, then actual output was also -1. Okay, in that case, what will happen? Your weight will decrease. Okay, in the AdaBoost algorithm we had discussed. So weight update formula for AdaBoost algorithm was something like this: weight I plus 1 is equals to wi into e raised to minus into the performance into y predicted into y actual. Okay, this was our weight update formula. So here what is given to you? Here I am given 5 data points to you. Okay, you have given 5 data points with the actual target value and predicted value. So out of this, first what I have to estimate is performance of the model. First, what I have to estimate is performance of the model, which is given by 1 upon 2 ln of 1 minus epsilon upon epsilon, where epsilon indicates what? It indicates the error in the model. And in the AdaBoost algorithm, how do we calculate the error? We calculate the error by weighted sum of all the misclassified, sum of the weights of all misclassified samples. So if you see what are the misclassified samples, the actual target value in the first one is -1. Here also it is predicted as -1. So in the second is also same. In the third one, the actual target predicted class was -1, but it was predicted as +1. So we have one misclassified data set, and in the last, if you see, there is another misclassified data set. So we have two misclassified samples. So two misclassified samples we have. So the error is equals to sum of the weight of the misclassified sample. So if you see what was the initial weight assigned to all of the data sample, 0.2 was the initial weight assigned to all the data samples. So the error will be 0.2 plus 0.2, which will be 0.4. Okay, we have calculated the error. Now, what will happen? We'll calculate the performance. In the similar manner, what we'll do, we'll calculate the performance using 1 upon 2 ln 1 minus epsilon upon epsilon. Using this formula, you may calculate the performance. And later, I have asked you to find out the weight update for the correctly classified sample. So correctly classified sample means wi plus 1 will be equals to wi into performance. Let us say performance equals to beta. So beta minus beta into y actual into y predicted. So if you see y actual, if it is -1, this will be also -1. And if it is +1, this will be also +1. So you can directly say this whole term will be equals to 1 only, right? So wi plus 1 will be equals to wi raised to minus beta. Sorry, e raised to minus beta. I'm sorry, e raised to minus beta. I forgot to mention this. Okay, e raised to minus beta into y pred into y actual. Okay, is this clear? Now, how to calculate the whole sum? Is it clear now, Priyank? Okay, fine. So let us proceed to the next question, which is uh, which of the following is true in the context of bagging algorithm? So I suppose everyone is boosting is a sequential process. Okay, I suppose this is clear. Okay. Okay, so next one. So which of the following methods are used to achieve diversity of classifier that make up the ensemble? So if you recall in the initial discussion of the ensemble learning also, we had discussed that ensemble learning must involve diversity in the models that they are combining. Okay, whenever we are combining multiple models to create an ensemble model, there must be diversity. Otherwise, we won't be able to achieve what we are there to achieve. We are there to achieve, for example, combining multiple weak models to create one strong model, but these models should also have diversity. So what are the methods to achieve those diversity? You can train different, you can use different training data set to train different classifier. Different group of features you may use, or you may use different hyperparameter value. Okay, all these three methods you may use to create diversity among the classifiers. I suppose everyone is clear, right? Okay. So next is, suppose in the Adabust algorithm, a limit is introduced on the weight that any point can take. Like, for example, the maximum weight that any point can take cannot exceed beyond 11 as in 11 units. So which one of the following is the possible effect of this modification? So what do you think? All of you, I would like to know from you. So both A and B, Janil says the second one. Yes, Priyank, second is also correct and first is also correct. So, Janil, so since see, the second idea is correct since final classifier becomes more robust to outliers. So this one is correct idea because, for example, if we have an outlier in the data set, so what will happen in the case of AdaBoost algorithm? It will keep on increasing the weight of that particular outlier in order to overfit. So it may result in overfitting the data set and to include the outlier in your particular classification, right? So that's why it may be, but the final classifier may become more robust to outliers. Means suppose we are telling that okay, the weight should not exceed beyond 11. So what it will do, it will automatically stop considering the outlier. So it will not include the outlier, right? And also it may reduce in lower overall performance. Yes, it can also result in overall performance reduction, because if you are not increasing the weight beyond 11, then it is possible that some of the samples may remain misclassified in your data set. Yes. So is it clear, Priyank, why both of them should be included here? Yes. What about others? Others are also clear, I suppose, right? Okay. Okay. Next one. Which of the following is true? This is quite easy. In the case of pessimistic pruning method. So anybody recalls what was pessimistic pruning method? What was pessimistic pruning method? Yes, error is added, right? So if you recall, there was something called generalization error, and okay, just a minute. So there was something called generalization error, and which was for the error of classification error that we had, and we had discussed something called pessimistic error, in which we were adding a penalty term in the calculated error, because we were estimating that the error that is calculated through the model is not correct. So what we'll be doing, we'll be adding a penalty term. So here the option 3 is correct based on what is given to us, right? Based on the each of the decision tree is constructed as a candidate for pruning. I suppose the first two are based on reduce error pruning and rule based pruning, right? So the third one is correct about pessimistic pruning, right? Okay, so the last one is quite easy. Which of the following hypothesis function in multinomial logistic regression, we use is softmax function, right? Okay. So this was about my section. I suppose all the doubts are cleared in this particular topic. So now we'll proceed with our next topic that we are going to discuss today. Okay. Also, I would like to inform give one information regarding lab work. So in the following lab, maybe in the upcoming lab, we'll be having an evaluation session. Okay, we'll be having an evaluation in which you'll be asked to present what you have done. So we may ask you questions regarding whatever lab practicals you have done. So by the end of this particular lab, by the end of this week, you have to upload you have to update, keep your repository updated till lab 7. So till lab 7, all the lab should be updated in your GitHub repository. In the meantime, I will create a assignment in the Google Classroom where you'll be asked to share your GitHub repository links. And later in the evaluation session when we'll be having, I'll be asking you to show me of all the practicals that you have done. So keep your repository updated by Saturday. So by Saturday, you have to upload all the lab assignment till lab 7. Okay, is it clear to everyone? So we'll be having an evaluation session probably this Saturday. I'll inform you on the next lecture that we have. Okay, by the next lecture, before next lecture, I'll be informing you that when is the evaluation session. So keep your repositories updated till lab 7. Okay, is it clear to everyone? Okay. So in the previous